Okay, ladies, so now that we have our structural formula for CH4, our number of bonding electron pairs, and our number of non-bonding electron pairs, we are going to use the worksheet I gave you to help find the bond angle and the perspective drawing or the 3D shape of this figure. So what we're going to do is we are going to take a look at this and find where I have 4 bonding electron pairs and 0 non-bonding electron pairs. So if you take a look at this, you'll notice that we have 4 non-bonding electron pairs in this area right here. So our 4 bonding electron pairs and our 0 non-bonding electron pairs is in this section right here. And as you can tell, this is my 4 bonding electron pairs. This is my 0 bonding electron pairs. My bond angle is 109.5 degrees. Our 3D shape is tetrahedral, and that means our perspective drawing should look like this, where our central atom is in the middle. I have 1 hydrogen up at the top, 1 hydrogen on the side, 1 hydrogen sticking out in front of us. That's what that dark color means. And the dashed line means I have 1 hydrogen sticking behind us. So let's go ahead and draw that. And if we go back to our picture, I'm going to scroll down over here. Right here. And like we said, it's a tetrahedral with 109.5 degrees. And to draw our picture, our central atom is carbon. So we draw the carbon right here. And we have 1 hydrogen sticking up, 1 hydrogen on the side, and a hydrogen over here, which should have an H, that means it's sticking out in front. And I have 1 hydrogen in the back, and that dashed line means it's sticking out in the back. Let's go ahead and do this for NH3. So let's start with our dot structure. Nitrogen has 5 valence electrons. Each hydrogen has 1. And so in order to make these pairs, this can create a bonding electron pair. This is the bonding electron pair, and this is the bonding electron pair. So let's clean it up with our structural formula. So our structural formula shows that I have a nitrogen in the middle, and we do our H's first horizontally and then vertically. And you notice up here, I still have these 2 electrons. So what I need to do is I still need to draw them in my structural formula. 1 and 2. So if I were to fill out my chart, my central atom is nitrogen. So if I take a look at my bonding electrons and I take a look at my non-bonding electrons, I see this nitrogen has 1, 2, 3 bonds. So that tells me I have 3 bonding electron pairs. And since I still have electrons left over, I see that this is 1 pair of non-bonding electrons. So I put a 1 over here. So let's go ahead and go back to our worksheet and find a 3 and a 1. So if I take a look over here, I'm going to go and find a 3 and a 1, and I notice that is right here. So when I look at this, there's my 3 bonding electron pairs, my 1 non-bonding electron pair. This bond angle is 107.5 degrees. And we are going to use our bolded shape. Our 3D shape is a trigonal pyramidal picture. And the picture looks very similar to our tetrahedral, except there is a pair of electrons at the top. So let's go ahead and sketch that for our problem. And if I go back to the next page and I scroll down, the first thing we're going to notice is it is up. Let me write in trigonal pyramidal. So it should say trigonal pyramidal, 107 degrees, and our central atom is a nitrogen. I have 2 electrons on the top. I have 1 H to the side, 1 H to the front, and I have this 1 H on this side. And remember, this is occurring because of VSEPR. So these these non-bonding electrons, they are very strong and they're repelling these hydrogens, so it causes this 3D structure. Okay? So let's go ahead and do one of these problems over here. For this one, let's just focus on hydrogen. And we won't worry about CO2 for right now. We'll take a look at that later on. But if I have hydrogen and oxygens, I have 2 hydrogens, 1 electron for each one. I have 6 electrons around oxygen. If I start connecting the dots, I can create a bond here and a bond here. So let's go ahead and draw our structural formula. Central atom is 0. I have an H on each side. And then I have to take a look at my valence, my leftover electrons. So if you notice, I have 1 pair right here, 1 pair right here. And just for symmetry's sake, let us put 1 pair at the top, 1 pair at the bottom. And if we are going to take a look at our bonding and non-bonding electrons, my central atom is oxygen. My bonding electrons and my pairs of non-bonding electrons. This has 2 bonds, so that gives me 2 bonding electron pairs. And it has a non-bonding electron pair up here and one down here, so that gives me a 2. Let's go ahead into our worksheet and find a 2 and a 2. And if you see, that 2 and a 2 is right here. And so my bond angle should be, my bond angle should be 104.5 degrees. My shape is called bent or V shape, and my drawing should look like this. So I have 1 hydrogen on the left, 1 on the right, and I have 2 electron pairs that look like antennas. So let's go ahead and draw that. Let me extend this. My central atom is oxygen. So I have an oxygen right here. I have the 2 valence electrons on each side, and I have my H's over here. And like we said, this is bent or V-shaped, and the degrees should be 104 degrees. Perfect. So what I would like you to do for practice is do the same exact thing. I would like to see, number 1, I'd like to see a dot structure. So number 1, show a dot structure. Number 2, a structural formula. Number 3, number of bonding electron pairs and number of non-bonding electron pairs. Number 4, I'd like you to give me a bond angle and a shape. Number 5, I'd like you to do the perspective drawing. Perspective drawing. And I'd like you to do these for the following examples. The first one would be AL Cl3. The next one would be for PBr3. And the last one would be for, I believe it was SF6. And if you want to see the answers, they are posted on Edmodo. So go ahead and try these out. and then I'll put up the next video. Thank you and good luck.